So this is about the theory. Let's look at the master chart what I've been talking about. This is how I solve the maze now. That makes sense to you. And you think that yes, you have a alternate approach now to solve the SQL questions. And you will not be in a situation where the question is asked, you don't. Are you a SQL beginner? You know SQL, but you just don't know how to solve the SQL queries. There is no better way than having the right logic in mind to solve the SQL queries. However, you cannot build that logic on day one. So in the meantime, try solving queries using the alternate approaches. One of such approach, I call it the maze approach to solve SQL queries. This is one of my many alternative approaches to solve SQL queries during interviews. The maze solution. Have you seen the maze puzzles in which you are offered multiple paths to start with and only one takes you to the end point? We'll apply similar approach to solve the SQL queries in this video. A maze approach can be an effective method for solving variety of SQL problems. One can develop a clearer understanding of the problem and develop strategies for finding a solution. For any given maze problem, there are three prerequisites. You should have a starting point, you should have an end point, and then there are some unknowns or uncertainties in between. So now the question is, does the maze approach applies to SQL as well? And in a way, it does. You have one or more input tables as the source rows. That becomes your starting point. You have one endpoint, which are your output or the target rows. And then there are some unknowns in between, which is basically the transformations or the business rules you have to apply on source rows to get the desired output. So if I give you this maze for a rabbit which has multiple paths to reach endpoint to get the carrot, how will you solve it? You may try this path, this path, this path, this path, right? But I'll show you how I do it. This is how I solve the maze now. You see, I started track backing from the end. Rather than starting from point A, I'm actually starting from point B, which is my end path. And you should also realize that I'm not track backing it completely to my starting point. I'm just starting a little bit, working backwards from the final output. And this gives me enough direction to understand which path I shall take. So we can solve the SQL using this reverse approach as well. This means we move from finish to start. So in this case, we have the final output. If the final output is not given, then still we can use this approach, but it will require more powerful imagination on your part to see how the output will look like from the given input. So what is maze approach for SQL problem solving? It involves three steps. The first step is you check the input and the output rows. You compare the input and output rows and notice if the number of rows have increased, decreased, or remained same. Similarly, in step 2, you will compare the input and output columns and notice if the number of columns have increased, decreased, or remained same. And the third step is you have to consider the commands. The SQL commands have impact on number of rows and columns in the output. Consider only those commands that are applicable to you in this case. What is the methodology for this maze approach to solve SQL queries? You identify the problem, begin by understanding the problem at hand and where it starts and ends. This means how many rows and columns to start with and end with. You determine your approach. Consider the possible SQL commands that can result in required output from the given input. Implement the initial solution. So start solving the problem using the chosen technique and continue until reaching the destination in an efficient manner. At the end, evaluate the outcome. Now you assess whether the solution arrived at the destination and if you can find any areas of improvement. So first, whatever the solution came into your mind, you implement it and then see whether you get the right output or not. Even if you get the correct output, you must iterate it one more time to find if there are any other SQL commands which you can use to further optimize the SQL query to make it more efficient, given that you get the same output at the end. So this is about the theory. Let's look at the master chart what I've been talking about. So what I have done here is I've come up with some of the most common SQL commands we use to solve SQL queries. And then I've tried to map it, the impact of those commands on the output rows and output columns. For creating this chart, I have assumed that there is an input table and it has 10 rows in it and 10 columns in it. So what will be the impact of any given SQL command on this table? Now the numbers 10 rows, 5 rows, 15 rows, these are hypothetical numbers. Basically, you should understand in the manner that if output rows is 5, but the input rows were 10, it means output has less number of rows than input. Similarly, if our output rows are 15 and the input rows are 10, it means output rows are more than the input rows. So from this, you should understand whether the input rows are same as the output rows, input rows are more than the output rows, and the input rows are less than the output rows. Similarly, we have to see whether the columns have increased in the output, decreased in the output, or it has remained same. So I will give a link to this chart in the description. You can download, you can look into it. You don't have to remember it by heart, but it will be a good starting point for you if you can just relate what is the impact of each SQL command. So say you are in a situation where you see that, okay, my output rows have decreased, but rest everything is same. So you can say, okay, I may use a where clause here because where clause generally reduces the number of rows, but it does not increase it. And there is no impact on the columns also. So I can use a where command here. I'm sure you're getting my point a little bit. So which command can impact rows and columns and in which manner? If you can relate to that, you can very easily pick, okay, I will use joins in this case because I have to increase the number of rows. With where filter, I cannot increase the number of rows. With a case statement, I cannot increase the number of rows. With a group by, I cannot increase the number of rows. I have to increase the number of rows. So in this case, either I will use joins or I will use a union operator. I hope I'm making some sense. If you can relate to what I am saying, drop a comment below by saying yes, so that I can understand the way I am teaching, you can relate to it, and I'll continue doing this. Okay, enough of the theory now. Can I show you this approach in action now? Sure, I will. Alright, so in this demo, I'll show you how different SQL commands impact the output rows and output columns. So we'll refer to our master chart where we have listed down all the SQL commands and what is the impact of it. I'll create two tables. One table is employee with the 10 columns and 10 rows. I'll create another table orders with 15 columns and 15 rows in it. So let me quickly create these tables. All the SQL I'll be using as part of this demo is available for you to download so that you can also practice this approach. Okay, so if I see here, I have an employees table. I'll just pin the tab. I have the order table. I just pin the tab. So you can see here, I have 10 rows for employees table and 10 columns in it. In orders, I have 15 rows and 15 columns. So what we'll do as part of this demo is, we'll go through each and every SQL command listed in master chart and we'll see what is the impact. Before we start, just for the easy reference, I'll add one comment here that it has rows 10 and columns 10. Similarly, for the orders table, we have rows 15 and column 15. Okay. The first command as per the master chart was where. So let's keep our base query as select star from employees. So we already know in the employees table, there are 10 rows and 10 columns. And as per the master chart, where will always reduce the number of rows or it will keep the rows as is, like the number of rows as is. It will never increase the number of rows, right? So say I apply some filter where position equal to developer and let me run this query and see the output. You see here, I got only 3 rows. So in the input, I have 10, but after applying the where, I have only 3. There is no way where I can apply the where condition to increase the number of rows. And when it comes to columns, there is no impact. So if I just run another query where gender equal to F, I get 5 rows in it, right? So there is no way where I can apply a where condition and it will give me more rows than the input rows. If I want all the rows, right, so either I apply a where condition which is applicable to all the rows considering the business columns, or I can just do where 1 equal to 1. So this will give me all rows and all columns. So what you have to see here is after applying where condition on any given SQL or any given table or the input rows, I cannot increase the number of rows. So if your output has more number of rows than your input, then where cannot help you to increase the number of rows. It does not mean that where is not required. It could be that we just want some developer position employees and then we want to do some joins to increase the number of rows, but where in itself cannot help you increase the number of rows in the output. All right. So we'll see the next command, which is order by. So order by as such does not have any impact on number of rows or number of columns as well. So let me do order by 1 and this. See here, it is giving all the 10 rows, all the 10 columns. There is no impact. I can do order by first name, descending. So you see here, it is sorted on the basis of first name. in descending order, but there is no impact on the number of rows in the output or number of columns in the output. It stays same, right? So order by is generally used for sorting the rows, but it does not have any impact on how many rows or the columns will come in the output. The next command in the master chart is limit. Limit, as per the master chart, can reduce the number of rows in the output. So we'll see this. So we can do limit 5. You see only 5 rows are there in the output, right? And it also says that limit cannot increase the number of rows, right? So say if I give limit 50, you see, I still get 10 rows only. The table has 10 rows. Even when I'm giving limit 15, it will give me 10 rows only. So limit 15 will not give you 15 rows because there are not even 15 rows in the table itself. So limit is also used to restrict the number of rows. It can reduce the number of rows or keep it same, but it cannot increase the number of rows in the output. If you have followed my course, SQL Pattern System, you know that there is a good combination of where, order by, and limit. All three comes together to solve so many SQL queries during interviews. If you have not checked it out, there is a free training for SQL Pattern System. Check the link in the description box below. Register for the free training. I'm sure it will help you a lot. That is another master alternate approach which I have come up to solve SQL queries. And the maze approach is just one part of it. Okay, next command we are going to see is joins. The join is actually, I'll not say it is tough, but it has more use cases and more types. Like you can have inner join, you can have left outer join, you can have full outer join, and there is a self join, which is nothing, which is just when the two tables are same, we call it a self join. It can be a left outer join, it can be an inner join. Just a different category we have given it. Special case, I can say. Okay. So in this case, say, let me try with the inner join first. I'll inner join employees and orders table on emp dot employee ID equal to order dot customer ID. So if I run this query, this is a very basic join query, right? So what output I'll get? I'll get 15 rows. I'm doing an inner join. I'll get 15 rows and I'll get all the columns. So 10 columns from employees will come and 15 columns from orders will come. So I'll get 25 columns and I'm getting 15 rows. So with join, we know that you can increase the number of rows. You can decrease the number of rows also, right? So this is the inner join. Inner join will only give you the matching rows. Hence, we are getting the 15 rows here. Let me just switch this join to left and then see what is the output. So if I run the query now, you see, I have 22 rows, right? So all the rows of the employees are coming. There are some employees who have not placed any order. So for that, there is no matching record from the orders table. It is coming as null. And I get 22 rows. So I'll just write it here also for the simplicity. Inner join gave me 15 rows and 25 columns, whereas left join gave me 22 rows and 15 and 25 columns. That's clear? So let me try the full outer join also. I'll see if it has any impact or not. So when I run the full outer join, I again get 22 rows and 25 columns. So I'll write it here also. So with full join, I get 22 rows and 25 columns. All right. So hope this is clear to you, right? And there's one more case. Let me cover that also. There is a right join also where orders table will become the driving table. So let me run this query and see. So with orders, you see, I get only 15 rows. And so with right join, I get 15 rows and 25 columns. If instead of star, if I use some column list, it will reduce the number of columns in the output. But it is very clear, right, that with joins, depending on what kind of join you are using, you can have different rows in the output. It can increase, it can decrease, it can remain same. So I hope this is clear to you. If joins is clear to you, please drop a comment saying yes, so that I know that whatever I am teaching is clear to you, and I shall continue doing it in this manner. Next command in the master chart is group by. So group by, we know it is used to create aggregates, and aggregate means that you are summarizing the data by creating some partitions and you're summarizing it. So the basic query is select star from employees, right? Now syntactically, I cannot do group by department ID. I cannot run this query, right? Why? I'll just run it. I'll show you the error. So you see here, employee ID must appear in the group by clause. So whatever is the non-aggregate column, right, that should come in the group by clause. I cannot write it like star. So I have to write department ID here. Group by generally we use when we are calculating some measures. So like count, max, something like that when we are doing, then we use the group by clause, right? So if I run this query, let me show you the output now. See here, I have grouped the input rows into 3 partitions: department ID 101, department ID 102, and department ID 103. And how many employees in each department? 433. So if you do 4 plus 3, 7, 7 plus 3, 10. So in employees, if you see, I have 10 records. And now after the group by, the count is still 10. But you see, I'm created a summary of the employee table. So from 10 rows, now I'm getting 3 rows in the output. So group by can definitely reduce the number of rows from the input. So let me give Elias name, and let me show you one more approach. Maximum salary as max salary from employees. So what if I want to run this query, right? So again, I just run this query and you see, I have 3 rows in the output, and I can increase the number of columns because whatever the aggregate columns I'm adding here, it is a extra derived column, and it is increasing the numbers of columns in the output. Like if I just do select department ID from employees, I have 1 column. But now I'm adding a new column to it. I've created a new column which does not exist in the table. So group by actually is increasing the number of columns in the output, and at the same time, it is reducing the number of rows coming from it. So from 10 rows, I got 3 rows only. But I'm adding few new additional columns to it, right? So just department ID and then 2 new columns, total employee and maximum salary, which does not exist in the table. I've created those. So if this is clear, let's move to the next SQL command, which is having. So group by and having works together in most of the cases. And in my course SQL Pattern System, I have explained it that group by, having, and aggregate functions, they work closely. And this is one of the most asked SQL commands in any SQL interview, where they will definitely ask you at least one question related with group by or having or using the aggregate functions, right? So coming to having, right, what we will do is let's use this query only. Further filter on top of your aggregated values, right? So let me do group by department ID and add having clause, having count star greater than 3. So now I want only those departments where we have at least 4 or more, like greater than 3. Now I want those departments where we have at least 4 or more records. Like count star greater than 3 means the total employees should be more than 3. So I have only one department, which is 101, and in that there are 4 employees. So you see here how the having also impacts. It reduces the rows further. Like from group by, we were getting 3 rows, but from having, after applying a having, it can reduce the number of rows in the output further from 3 to 1, depending on what condition you are using. So having is also used to reduce the rows. What you are given in the input, the output can have further less number of rows. This is clear. We'll quickly move to the next, which is case statement. So in case statement, right, I will just go back to my default query, select star from employees, right? Now, say I want to add, case is generally used like a if-else statement, where I want to, depending on some value, I want a different output values, but those scenarios can be multiple. It's like if the value is this, then do this. If the value is this, then do this. Generally, the check happens on the same column. So let me create one new column here, right? So let's do current date minus hire date is less than 365. Then I'll say that, okay, less than 1 year. Okay. And so basically, I'm trying to create a new column where if the duration of the employee is less than 1 year, or it is between 1 year and 2 years, or it is more than 5 years, like that, right? So I will do minus 365. So I'm just checking for 2 years, then between 1 year and 2 years. Similarly, I can write when current date minus hired date is less than 365 and 5, then between 2 years and 5 years, else more than 5 years, and now I'm giving this column as a tenure as the name. So I'll run this query and show it to you. So as you see at the end, there will be a new column: more than 5 years, more than 5 years, more than 5 years, between 2 years and 5 years, less than 1 year, between 1 year. So you see, with case statement, there is no impact on number of rows. Case statement used in the select clause can never reduce the number of rows or increase the number of rows. The number of rows will always remain same in the output. But if I want a new column, then case statement can help you in increasing the number of columns in the output. You can create more derived columns using case statement. Right? So if this is clear to you, let's move to the next SQL command in the master chart, which is window function. Obviously, there are a lot of assumptions I have made to keep this thing simple. But my point here is, if you can understand, and whatever I am teaching you, if that makes sense to you, and you think that, yes, you have a alternate approach now to solve the SQL questions, and you will not be in a situation where the question is asked and you don't know what to type, then give me a thumbs up in this video. Okay, so the window function, many people get confused by the group by. Group by will always reduce your number of rows in the output, or it will remain same if there are just one row in each partition. But window function will never reduce your number of rows. So window function is generally used in the select clause. If it is used in the where condition, then it's a different thing. Where will always reduce the number of rows or will keep the same. But window function will never reduce your number of rows. It will always keep it same. Only thing is you will have a separate column, a new column corresponding to your window function. So you see here, I've created a new window function where maximum of salary I've created for each department and associated it with each row. So in the output, you see again, I have 10 rows in the output and 11 columns. Our extra column is added, right? So similarly, let me add max is very often used. Max, sum, min, these are very oftenly used window functions. Another window function is lead and lag, which is very oftenly used. So what I'll do here is I'll keep it like this, and maybe I will do next higher date here. What I'm trying to calculate here is, okay, as per this window function, I just want to see that, okay, which person was hired next after this person. So if you see here, this person was hired on 2005. The next hire date was in that department was 2010. And 2010 is this person when it was hired. Next hire date was 2019 for this department. In 2019, then 2023 was the next hire date. So in which department, where was the next hire date corresponding to each employee? That's what we are seeing here. So this is just a random SQL query to show you that using window function will not reduce the number of rows in the output, but it may increase the number of columns in the output, right? So if this is clear, we move to the next SQL command in the master chart, which is union. Union, select employee ID. With union, all the select block should have the same number of columns, else it will throw error. So what I will do here is, instead of using select star, I'll just list some columns here. And let me run the same query with the union and let's see what is the output, right? So if I run this query, let's see what is the output. See here, I have 10 rows only and there are no duplicates, 3 columns. So I selected 3 columns and in the output, I have 10 rows only. So union can reduce the number of rows. Say there are a lot of duplicates. So right now I have 10 rows coming from this, yes, and 10 rows coming from this block. In the output, I have 10 rows only. It has removed all the duplicates. So union can reduce the number of rows. Union can also increase the number of rows. I just add one as union set. Let me add a new column here to make each row. Add another column here to make each row distinct. And then let's see the output. So you see here what happens. I have 10 rows from first union block and then I have 10 rows. So in total, I got 20 rows now. So union can increase the number of rows. It can keep it same. There are no duplicates, and it can reduce the number of rows if there are duplicates in your set, right? Now, let's see the same example with union or also, right? So we have the next command in our master chart is union or, and we use something similar. We'll just remove this column and we'll see what is the output. So union all, as we know, it does not remove the duplicates. Whatever rows are there, it will come as is. So you see here, there are 10 rows in union. And if I do a union all, I will get 20 rows in the output. So union all, keep the rows same. It does not reduce the number of rows. It does not remove duplicates. It keeps the rows as is. Next is in the master chart is another set operator, which is except. Except means that you are looking for records which are present in one data set and are not present in another data set. This will generally what will happen. This will reduce the number of rows because you can see here all the rows, 10 rows which are present here also. So the output does not have any record. So in this case, except will always reduce the number of rows or will keep it same. It will never increase the number. Similarly, moving to the next command in SQL chart, which is intersect. Intersect is the opposite of except, where it will only give you the matching records from both the places, right? So if I do this, you see, I again get the 10 records. So all the rows, 10 rows which are present here in first select block are present here in second block also. So both the select blocks are giving the same rows, else the output has 10 rows, right? So you see here, intersect will never increase the number of rows. It will keep it same or it will further reduce it. The last option is in. So in is generally used in a filter condition where we want to filter out some records on the basis of multiple values and not just one. So say I give gender in M, and then let's see the output, how many rows I get in the output. If you see here from 10 rows, now I'm getting just 5 rows because I have applied a filter to give me only those records where gender is M. Now we'll add one more query here where say position we know in class we can give multiple values. It can have more than one. So say developer, manager, and we'll see the query now. So you see here, I got 7 rows in the output. in condition generally will not increase the number of rows, it will reduce, and it works very closely with the where condition. So you can create subqueries and you can give hard-coded values to filter out, and it works with the where condition. So where generally is used to reduce the number of rows. So yes, this is all I wanted to cover as part of this demo. And I hope now the theory makes more sense after looking into all these commands now. If this makes more sense and it brings more clarity, don't forget to leave a like on this video. I worked very hard to come up with for this approach. All right, so let's go back to the presentation. I hope the SQL examples I shared with you can help you relate more to the theory part. If this looks good to you, I'll also try to compare with the traditional approach. I will reiterate, there is no better way of solving SQL queries than having the best logic in your mind. But if you don't have that logic, if you're still not there, then you can use this alternate approach. And I just compared it. The traditional approach is time consuming because you have to practice a lot. You have to spend a lot of man hours to understand the SQL, how things work, and it is time consuming. Sometimes people also find like it's a block road. They don't know how to move forward. They are reading the question again and again, but nothing is coming in your mind. It is prone to errors because if you don't have a proper strategy and you are yet not there, you don't have the logic part also, then you are prone to use different SQL commands which may not give you correct output. Like I've seen so many times, people use group by instead of window function and they never get the right output. People try to use case statement instead of join to get some extra columns, but cannot increase the number of rows in the output. So it is more prone to errors. It is so much dependent on your logic. If you don't have the right logic, the traditional approach is prone to errors. Now coming to the maze approach, it is effective in solving complex problems. Why? Because you are working backwards from the output. You can divide your complex problem statement into smaller problems and solve one at a time by applying specific SQL commands on that small problems. It saves time because building logic takes time. But with this approach, you can start solving SQL queries within the next few minutes. It also improves your accuracy. As and when you are implementing this approach, you will see that your accuracy also will increase. Some of the key benefits of maze approach is it encourages experimentation with SQL. So with this approach, you are experimenting with SQL. Can I try this approach? I know that, okay, I have to increase the number of rows in the output. Can I try join? Can I try union? Can I try union all? Or if I have to reduce the number of rows, shall I try where here? So you are experimenting here to match the input with the output. And when you are doing experiments, it will enhance your learning by default. It reduces risk of failure. You already know the output, you already know the input, you already know what your command is supposed to do. So when you know all these three components you put together, there are less chances of failures. It allows creative thinking. Trust me, after spending 15 years with SQL, I can tell you that there is more than one way of solving each and every SQL problem in the world. There will always be more than one solution to the same problem. So it also allows you to enhance your creative thinking. Can I do it in this manner? Can I use joins here? Can I use window function here? So it will push your creative thinking as well. And it also enables problem solving attitude. You have a better attitude towards solving the SQL queries because you have an alternate approach. You are not following any fixed path. If you really like this alternate approach of solving the SQL queries, there are a few ways I can help you. If you need more information about this approach, you can drop me an email, support@etlsql.com, asking your questions, and I'll try to answer it. I also conduct a monthly workshop. You can find the link in the description box below. Enroll for the monthly workshop where I'll explain you this maze approach, solving real life questions from the top companies from across different platforms using this approach. Or you can join my self-paced course, SQL Pattern System, in which I continue to share a lot of different approaches to solve SQL queries. The course is not for SQL for beginners. The course assumes that you already are aware of SQL commands. It's just that you need some little push to solve SQL queries during interviews. So if you know SQL, but you still cannot solve the SQL queries during interviews, then this is the right course for you. And in this course, you will find a maze approach as a bonus. So in these three ways, I can help you. If you find this video helpful, if you think this approach can help you solve your next SQL queries, drop me a like, share it with your friends. If not already subscribed, do subscribe to my channel now.